Sorry about that. I just realised I had the microphone off, so I got the microphone on again. I'm going to give you 5 minutes to do part A of this question because it's quite a big question, and then we'll go through that, and then we'll move on to parts B and C after I've had a go at that. So I'm going to give you 5 minutes to have a go at just part A, and see if you can do it in that time. That really does mean you know this topic well enough for you to be ready to do it in the exam. So off you go. Right, so here we go. We're going to go through just part A of this question to start off with. Now, the first thing I always look at is when you see this tan theta equals 5/12, is to actually use that and draw the triangle of what that means. So if you've got features there and you've got 5 and you've got 12, then we're going to have 13 over here. So sine theta will equal 5/13, and cos of theta will equal 12/13. So we've got those ratios ready. We also know that mu is going to be equal to 2/3. I always like to write down all the information I have in the question. So from that, we know that F equals mu R, so therefore F equals 2/3 of R is also something we're going to be needing to be doing. Let's draw the forces. We're going to have our normal reaction here. Okay. On B, we're going to have friction acting down the plane, going this way. We're going to have 3G, the weight, acting down, and then we're going to have the tension. So if we're looking at B, the tension acts this way. Then we've got tension acting up from A, and then we've got the weight of A acting down this way, 7G. So we've got the whole system is going to accelerate this way for that, and this way for that. So if we resolve on B to start with, and what we're going to do is we're going to resolve parallel to the plane. And from that, we can see that we've got the mass times the acceleration, the resultant force. So we're going to have 3A, because the mass is 3, is going to be equal to the tension minus the friction and minus this component of 3G, which is going to be acting that way. So that's going to be the sine theta component. So we've got tension minus friction minus 3G, and it's going to be sine theta. It's going to be times by. So let's just put some more things into there. So that's going to be T. We know that F equals 2/3 of R. And we know we've got 3G times 5/13. So that's going to be minus 15/13G there. Sine theta is 5/13. Now, if we also resolve on B, but this time we're going to resolve perpendicular to the plane to find out what R is equal to. So R is going to just equal 3G cos theta because it's in equilibrium this way. The acceleration's all that way. This is perpendicular to acceleration, so we're in equilibrium. Therefore, we have R will equal 3G cos theta. So that's going to be equal to, cos theta is 12/3, so we get 36G/13 here. Now, if we substitute this into here, because we've got R here, so substitute 2 into 1, we're going to get 3A will equal T, and then we're just going to get, if we go 2/3 times all of this, minus 15G/13, that'll give me 39G/13, which is obviously just 3G. Now, if we then resolve on A, and let's go that way, and we're going to have the MA, so it's 7A will equal 7G minus T. Let's just rub this out and turn this into a 3G just to make it look a bit nicer. 3G. So we now got equations 3 and equations 4. And we want to find the acceleration. So if we add these two equations together, we'll get 10A. So 3 plus 4. 10A will equal 4G. So therefore, A will equal 4G/10 meters per second squared. Right, so that's part A. Part B is what, 6 minutes worth? Let's give you 3 minutes to have a go and see how far you can get into that, because it's a lot shorter than part A. So 3 minutes in your own time, part B and C. Right, so what we do know is that we want to find the speed of B when it has moved 1 meter up the plane. So for part B, what we do know is S equals 1 meter. We know that A is equal to 4g over 10, and we know that U will equal 0. So what we're going to do here is we're going to use V squared equals U squared plus 2AS. So V squared will equal 2 times 4g over 10, and that means that V comes out to be 2.8 meters per second. Now, for the second part, probably going to need a little bit more space to work this out. So let's just create a bit more space on my screen. I think that's going to be enough. So what we're going to do for the second part, when B is moved 1 meter at the plane, the string breaks. Given the subsequent motion of B does not reach P, find the time between the instance when the string breaks and B comes to rest. So what's going to happen is we're going to have a new acceleration here. So if we got our inclined plane, we're going to have our normal reaction here. We're going to have our friction still acting down here, and we're going to have 3g still going this way. So working parallel, okay. The MA, let's actually just undo that. Let's just put the A acting this way because it will be, because it's going to be caused by the friction. So therefore MA, so 3A, will equal the friction. Sorry, I just looked at, I've just noticed something, a little bit of a mistake on my previously worked out answers. Basically what I do is, just to make sure I don't go wrong, I have my previously worked out answer on the screen as well. So I'll just show you that. I had a minus sign in here, which had obviously accidentally got rubbed into a minus sign when it should be 3g sine theta here, because we're going to have this component, that's theta, we're going to have this component 3g acting down the plane as well. So we'll have 3a will equal 24g over 13. The friction doesn't change, okay, because there was no change in the normal reaction, so therefore the friction does not change. So you get 24g over 13 minus 15g over 13 when we work that out. And that all comes out to be 9. What am I going to get? So I want a plus there. Still got the minus sign from before. So that gives me 39g over 13, which gives me 3g. And then divide that by 3, I get A is just equal to g meters per second squared. So I know that A equals G, so I'm going to use V equals U plus AT because I want to find the time. And we know that V is going to be 0 because that's when it comes to rest. We know my U is my old V from here, 2.8. And we're going to take away dt from that. So T will equal 2.8 over 9.8, which comes out to be about 0.286 seconds. Okay, so that's our first question. Our next question, I'm going to give you 7 minutes to have a go at. So here is our next question. He says paging down. And I press the right thing. There we go. Next. Right, let's look at this question then. So we have got a particle mass 0.4 kilogram being held at rest on a rough horizontal plane. Okay, so rough plane by horizontal force P. So P is acting horizontally. Force acts in a vertical plane. What that means in a vertical plane, if you just cut to straight down through the plane, that's what it means by the vertical plane. But all the forces we're going to have. So if we draw these, they're all in one vertical plane. There's none that's sort of skewed to the side or anything. So this one is going to act, the weight's going to act straight down. So we've got 0.4 G acting straight down there. And we've also got the normal reaction acting this way. Now, what else have we got? Given the particles on the point of moving, sliding up the plane, so the friction's going to be acting down the plane here. We've got tan alpha again given to us, so that's equal to 3/4. So therefore, if we draw a little 3/4, there's 3, there's 4, there's 5. We're going to get sine alpha equals 3/5. And we're going to get cos alpha equals 4/5 here. Find the magnitude of the normal reaction between the particle and the plane. So let's resolve. And we're going to start off by resolving perpendicular to the plane. Now this is going to be a little bit more complicated because of the Pn we've got going on here. So we have our normal reaction. We're going to be in equilibrium. It's actually in equilibrium all the way around. So moving up, moving down, moving wherever. It's only on the point moving, so it's in equilibrium. So we've got R, which is going upwards, and then we've got P, which is acting the other way, the other side of the plane. Okay. So we've got, if that's alpha, this is P. If we continue P through here, then that's going to be the P sine alpha. And we've also got a bit of mg acting perpendicular to the plane. So that's alpha, so it's going to be mg cos alpha. So R will equal 0.4 g cos alpha plus P sine alpha. And what we have here is we can write that R is equal to, we're going to have 16 g over 50 plus 3p over 5 once we work that all out. Now if we resolve next in the perpendicular direction to that, which is going to be parallel to the plane, we're going to have the F plus this component of mg, so plus 0.4 g sine alpha equals, now parallel to the plane, we're going to have a bit of this P acting, so it's going to be P cos alpha acting parallel to the plane. So we've got F plus 12g over 50 equals 4p over 5. So if we rearrange, so let's put R in. Sorry, we also know that F equals mu R. And I think we're told mu is 1/3, so F equals R over 3. So we've got R over 3 equals 12 plus 12 over g over 50 equals 4p over 5. Rearrange all of that to get p as a subject, because we're going to try and find the magnitude of normal reaction. We don't need to find p to start off with. Okay, so we're going to find the magnitude of the normal reaction. It doesn't really matter which order you do it in. You can do part A and part B in equal order. So we're going to get P equals 5R over 12. 5R over... yes, because I'm going to times by 5 and divide by 4 to do. Plus 3G over 10. Now I've got my equation 1 up here, and I've got my equation 2 here. So I'm going to substitute equation 2 into equation 1. So I will get R is equal to 16G over 50 plus 3/5 of all of this. Okay, and we can simplify that out to, you get to a stage of 3/4 R, I think I got out. Well, I multiply out the brackets. I'm going to write 3/4 R equals 25 G over 50. And so I get R is equal to 2G over 3, 2/3 G, or 6.5 to 2SF. Okay, that gives us R. And then we want to find the value of P, which really, if you've got R, then P is not really worth 5 marks because you just substitute it straight into here. So we're going to get P for part B will equal 5/12 times by what we got for R, which is 2G over 3 plus 3G over 10. And if we work that all out, we get 26 over 45G, which is 5.7 to 2SF, if you want to know what the decimal value of that is. So there we go. That is that question. Let's move down to the next question. For some reason, not moving down. Okay, for some reason, my scroll button is zooming in and out. Sorry about this. Funny how these things just suddenly change. Right, so used to scrolling. I'm going to have to just do it this way. Scroll in a bit. So used to scrolling up. There we go. So we got into the question. Right. It's a 15 marker. Let's give you 7 minutes to have a go at this question. Right. So here we go. So let's get the zoom out. Friendly manner. Okay, it's gone back to scrolling for me. That's nice. Excellent. Right, so we're looking at this question. We've got two particles, P and Q, 4 kilograms, and so that's 4g, and then we've got 0.5g here, respectively. The particles attached to the ends of a light, inextensible string. Particle P is held at rest on a fixed rough plane, which is inclined at a horizontal angle alpha, where tan alpha equals 4/3. So we've gotten quite used to this. So we've got 4, 3, 5 this time for alpha. So sine alpha will equal 4/5 this time, and cos alpha will equal 3/5 this time. Right. Sorry, I just had to click on something there. The coefficient of friction between the plane, between P and the plane is 0.5, so we know that mu equals 0.5. The string lies along the plane and passes over a small light pulley. Plane Q hangs vertically below. String lies in a vertical plane, contains a pulley line and greater inclined plane. Particle P is released and rests, and the string taut slides down the plane. So friction is going to go this way. And we're going to have tension this way. And we're going to have our normal reaction going this way and tension that way on Q. And the thing is going to accelerate this way and this way. So that's our question. So if we resolve on P to start with, and we'll do parallel to the plane. Okay, we're going to go this way. We're going to have 4A, the resultant force. I always like to think of this as the resultant force is acting down the plane. So it's going to be equal to everything in the same direction minus everything in the opposite direction. So we're going to have the 4G sine alpha, because alpha's over here, so it's the opposite, so it's sine alpha. So we get 4G sine alpha minus T minus F. And then we're going to do on P perpendicular. And we're going to get R is equal to 4G cos alpha. And so therefore R is equal to 12G over 5. Now we know that F equals mu R, so therefore F will equal half of that. So F will equal, what's that, 6G over 5 from that. To put these into, substitute into equation 1. So that's meant to be a 1 there. Not a very good one. Let's just rub that out and put a proper 1 in. Okay, so substitute into 1. And what we get is we get 4A equals 4G sine alpha, which comes out to be 16G over 5 minus T minus G over 5. So that's going to give me 10G over 5, isn't it? So I'm going to get 4A equals 10G over 5 minus T. And I'm going to call that equation 2. Now, on Q, going down, we're going to have 0.5A will equal 0.5G minus T. And I've just done that the wrong way around. Sorry about that. Because it's accelerating this way. So it's going to be T minus 0.5G. Now what I can do is I can substitute this straight into here because I want to find tension. So if 0.5A is equal to this, then A will equal 2 lots of that minus G, so times it by 4. And I'm going to get, let's just substitute 3 into 2, and I should get 8T minus 4G equals 2G minus T. So what I'm doing is taking this, putting it in here, and timesing it effectively. In fact, it's times by 2, so I get 2G minus G, 2T minus G, times by 4 gives me 8T minus 4G. And from this, I can get rearrange to get t is equal to 2g over 3. Now, normally, what we do these questions, you normally just add them together and the t's cancel and you find a first. But in this case, what we've done is we find the t, and we don't need to find a at all in this question. The magnitude of the resultant force exerted by the string and the pulley. Now, I'm guessing a lot of you found this little bit quite tricky. So we've got t going that way, and we've got t going that way. Now, what I'm going to do is I'm going to replace this t with a t going that way here. And then my resultant is going to be, let's make it a black pen. So that's going to be my resultant force. So we know that this angle here is going to, so that angle there will be alpha. This is 90 minus alpha. So we can find the horizontal component and the vertical component of t. So our resultant is going to be squared is going to be equal to the horizontal component of t squared. So we want t, what's that going to be? Cos alpha. Cos alpha will be our horizontal component here, all squared. Plus, and she's going to be a bit more than t because you've got the t there, and then we've got this vertical component of that t. So we're going to have a plus t sine alpha all squared. Okay, that will give me my resultant force here. That's one way to do it. There's lots of there's other ways to do this question. That's just the way I happen to chosen to set this one up. So what I do is I put those values in, and I get something like, what do I get? I get r squared will equal, I think I get 36g squared over 225 for this one, plus 18 squared, I can't bother to work it out, over g squared over 225 for this one. And when you add those two together and square root, you get r is equal to 12.39 to 2 dp. Okay, if you want the exact value, it's 98 root 10 over 25 if you want to stick with exact values in the question. Okay, so quite a tricky one to set up. You just got to realize that the resultant force you can find by basically just taking these two forces. You've got the tension here and the tension here. If we take that tension and just put it on the end of that tension, then we can find the resultant force that way. There are other ways to find it, okay? Because if you look at the pulley, the only thing it feels pulling on it will be the tension that way and the tension that way, okay? And that's how I got this diagram. And then I was able to add the tensions together to get my resultant force that acts on the pulley. And obviously, the pulley will push back on the tension in exactly the opposite direction. Okay, if you happen to have to do that part of the question, which we don't in this case. So, moving down to our next question, which I think, have a look, how long we're going to have it, 14 markers. We're going to give ourselves 7 minutes to have a go at this question. There we go. Let's just zoom out a bit for you so you can see it more easily. So 7 minutes, off you go. Right, let's go on this last question. This is the last one we're going to do today. So we've got a force that's not pulling parallel or perpendicular to the plane. Okay, we've got a mass of 4 kilograms, so we've got 4G acting vertically downwards. We know it's moving through a rough but constant speed, 60 meters per second, so it's in equilibrium under the action of a force, magnitude 36 newtons. The plane is inclined at 30 degrees to the horizon. The force acts in a vertical plane, connecting line lines. So we're going to have a normal reaction here. Okay, 30 degrees. The coefficient between P and the plane mu is in the plane is mu. Find the magnitude of normal reaction between the plane and find the value of mu. Now it's moving up the plane, so therefore friction must be acting down the plane. If we're going to move up the plane, the friction will oppose our motion. So first of all, let's just resolve the perpendicular. So we're going to do perpendicular to our plane, and we're going to get R plus the perpendicular component of the 36. So we're going to get 36, and that's going to be sine 30 degrees equals this component of our mg. So we're going to get 4g cos 30. So we can rearrange this to get R is equal to 2 root 3g minus 18, which comes out to be about 15.9. So that gives us the normal reaction that we've been asked for. We know that F equals mu R. So what we need to do is we need to find F. So let's resolve parallel to the plane. And we get 36 cos 30 acting up the plane. Okay, this bit, so it's next to the angle, so it's going to be cos. And that's going to be equaling the F and the mg acting down the plane. So we're going to have F and we're going to have mg sine 30, because this bit's going to be 30 here. So we're going to have, what could be? This could be 4g sine of 30 acting down the plane there. So rearrange this and we get F is equal to 18 root 3 minus 2g. When we've rearranged all of that, we take, sine of 30 is equal to half, so that gives me 2g. Take it away from this. This is 18 root 3. So therefore, mu is going to equal F divided by R. So it's F divided by all of that. So mu will equal 18 root 3 minus 2g. If we want to stick to exact values, we can do 2 root 3g minus 18 over here. And it all comes out to be about 0.7322 F. The magnitude of the 36 newtons is removed. Find the distance that P travels between the instant when the force is removed and the instant when it comes to rest. So we've now got to re-look at our problem because the normal reactions change. So therefore the friction will change in this question, and therefore our acceleration will change. So we've now got our R here. We're going to have friction because it's still going to be moving that way and it's going to be slowing down. We're going to have a friction that way, and we're going to have mg still acting this way. Okay. So we get R is equal to just 4g cos theta. So 4g cos 30. Still at 30 degrees here. And this will still be 30 degrees, so the cos 30 there. And then if we resolve, so that was resolving perpendicular, wasn't it? Sorry, I didn't say what I was doing. That's really bad. Resolve perpendicular, we get that. Resolve parallel to the plane. Okay. We're going to have MA, which is going to be 4. The resultant force will be 4A, and that'll be equal to everything in the same direction, minus everything in the opposite direction. So it's going to be F, which is equal to mu R. The F, which is equal to mu R, and we've got mu is 0.73, and we've got R is equal to this. So we're going to have 0.73 times the 4g cos of 30 for your F. And then we're also going to have this 4g sine of 30 going on here. And we can rearrange all of that, find out what A is, and we get A is equal to about 11.06. remember when you put this 0.73, you don't put that in, you put in the accurate value for mu in to work out this value, then to add that, and then you find your A from that. Now, we want to find the distance that he moves. So we're going to use v squared equals u squared minus 2as. So what we've got is well, it's going to be 0 for the v, 16 for the u, so 16 squared minus 2 times 11, and the rest times by s. So therefore s will equal the 16 squared over 2 times 11.06. And once you've worked that all out, remember, you again don't just put the 11.06, you put the most accurate value into this equation, and you only round at the end of the question. So we get 11.57 meters to 4 significant figures for our final answer. Okay, that will do for today. I think we've been streaming for an hour on these questions. These are all much longer questions. They tend to be the end of paper questions. I know I haven't done this question here, and I'm not going to propose to stream the answer to this question. That's one for those in my classes doing the revision sheet. That's one for you to have a go at. Of course, they do have access to the answer, so I'll just put it on screen so those you just watching the stream and not in my class can have a screenshot of this, or those you watch the video later. And then what I'll do is I'll just scroll down to the model answer for question 18. Not model answer, the mark scheme. So question 18, so there's the mark scheme for question 18. So you can again pause the video and have a look at that. So next stream, we're going to do another one tomorrow, which will be on the pure math section. Same time, same place. See you then.